In order to compare the means of two independent populations with unknown variances, we will be using a two-means t-test. Let's consider an example comparing the mean sales at two different stores. Store A underwent a change to the store layout, so the parent company wants to compare its sales to that of another store in the same area to see if the sales are significantly higher at Store A. A meaningful difference would be an increase of more than $5,000 in weekly sales. The dataset has been uploaded to our project and can be viewed and edited from the Data Sources panel. You can see that there are two samples of different sizes, one from each store, showing the weekly sales in thousands over the past year. To use the test, navigate to the Analyze section of the DMAIC menu, and under the Parametric submenu, you will find the two samples t-test. We see that the first step of the two samples t-test accepts a single data variable, which must be numeric. If we don't have the actual or raw data, we can provide summary data for our samples by specifying the population group names, sample sizes, the means, and the standard deviations of the two samples, which we will demonstrate later in this video. To use the raw data, we will navigate to the Store A variable and drag it onto our Studies Data variable dropdown. This is our first sample. After attaching the first data variable, we are prompted to attach either one more data variable, which must be numeric, or a grouping variable which can be numeric, text, or date time. We will continue by dragging the Store B variable onto the New Data variable dropzone. The order of dragging on the variables is important because the first variable attached to the study is always treated as sample 1, and the second variable is sample 2. In particular, when comparing samples that are separated in time, such as before and after a training seminar, you must be careful to specify which sample is treated as the first one, and set up your alternative hypothesis to reflect the claim accordingly. In this example, we will be testing whether mean sales for Store A is greater than the mean sales for Store B by a certain amount. Once we drag on the Store B variable, notice that the grouping variable dropzone disappears, indicating that the grouping variable is only valid with one data variable. We will discuss grouping later in this video. After providing the two sample variables, the tool will prompt us with a series of study options. The alternative hypothesis should state our concern, in this case, that the hypothesized difference in mean weekly sales of Store A over Store B is greater than $5,000. Select greater than for the alternative hypothesis. We then have the option of changing our significance level from its default value of 0.05. We will keep this value, meaning that if the p-value from the test is smaller than 0.05, we will reject the null hypothesis and conclude that Store A's weekly sales are indeed greater than Store B's by more than $5,000. Lastly, we specified the claimed or hypothesized difference between the two means that we're testing for. In our case, because we would like to see if changing the store layout in Store A led to an increase in mean weekly sales of more than $5,000, and because our measurements are in the thousands, we should enter 5 as our hypothesized mean difference. Once we're done specifying all 3 study options, the Continue button becomes active. We can click the Continue button, beginning our calculations. Once the calculations are complete, you will be presented with the sample summary, hypothesis test results, and most importantly, the test conclusion. In this case, we can conclude that the difference of the means of Store A and Store B is greater than 5 because the p-value is less than the specified alpha value. You can modify the test setup by visiting the Study Setup drop-down menu. Additionally, assumptions were made concerning your data in order to run this hypothesis test. These assumptions and their validations can be viewed in the Assumptions dropdown. If we wish to use the Summary Data option, we must first drag off the attached variables or open a new study. Let's see how we would use the Summary Data option. To do so, first drag off the 2 data variables. Then we can enter the name of the samples as Store A and Store B. The sample sizes is 15 and 25, the means is 37.47 and 29.08, and the standard deviation is 5.68 and 4.8. Now the Continue button becomes active, so click the button to advance to the study options. Here we will select the same options as before, meaning the greater than alternative hypothesis, leave the significance level at 0.05, and a hypothesized difference of 5. After all the options are specified, we will click the Continue button to run the calculations. Once again, you will be presented with the summary data that you entered in the last step, the hypothesis test results, and the test conclusion. Note that some summary statistics are omitted from this output because it is not possible to calculate them from the summary data provided. Similarly, the box plot graph is omitted since the actual data are not available for graphing. If we wish to use the grouping variable to identify the two samples which are combined in a single column, the grouping variable must be a single column with exactly two unique values assigning each row of your data to one of the two groups under study. For this reason, if using a grouping variable, it must be the same size as your combined data variable, even if the sample sizes are different. When setting up your study, instead of dragging on two data variables, you will drag on one data variable and then the grouping variable. This concludes our tutorial. You can check out more tutorials at www.moresteam.com/help/engineroom.